the next presenter is, let's see, Manny Pimenta, right?
Yep.
And Manny is an electrical engineer with a computer science master degree as well. He has worked in electric utility industry and with airborne radar systems. His primary interest at the moment is space colonization, and his focus on establishing a permanent human presence on the moon, which I'm sure all of us agree with. He has been part of releasing the world's first fully immersive interactive virtual reality simulation of the moon, and has been presenting at space conferences and other lectures and workshops at NASA and other places. And if you missed something important, feel free to add. And the floor, the air, and the ether is yours for at least 20 minutes. Well, 30 essentially.
Thank you very much, Nicholas. Can you see my screen?
Yes.
Okay. Great. Thank you very much for the introduction. I think you hit all the important parts. I also want to thank the Moon Society for putting on this event. I'm always happy and excited to speak with fellow moon enthusiasts. So my latest venture related to space is founding Virtual Moon LLC. We'll talk more about that further down, but the topic of my talk is to think beyond just the current plans for lunar bases and outposts. So we're all familiar with the existing plans from different organizations, different countries. Everybody seems to have a plan for returning to the moon and establish some kind of a outpost or a lunar base or a research facility of some kind. And these are, of course, ambitious plans. The type of installations we're talking about would kind of look like what I'm showing you here. So the NASA Artemis base or the Open Lunar Foundation Moon Village. These are essentially, high-tech campsites. They're not designed for comfort. Of course, they'll design as much comfort as is possible, but because of the limitations involved, they're going to be fairly rugged environments and also a fair amount of danger. The more ambitious plans that they have for, let's say, next stage facilities are, for example, the Artemis base that's Andy Weir describes in his Artemis novel, and that's maybe a 10x scale from what we were talking about before, and this first generation of lunar bases and lunar outposts. But you'll notice here that Andy's prediction is that this is something that could be buildable by 2080, about 50 years, over 50 years from now. And then sort of on the other extreme, we have the Shackleton Crater Dome, which is a very ambitious, very advanced installation where you build a dome over the Shackleton Crater, 25 miles in diameter. And this, of course, is currently out of reach, and it probably will be out of reach for the next century, perhaps. We won't be in a position to build anything like that for 100 years, maybe more. So first, just to take a step back, talking a little bit about Virtual Moon. So we created Virtual Moon to build a very high accuracy and highly detailed photorealistic virtual simulation of the moon. It's a virtual reality immersive experience that people can so people can have a very realistic visual experience of what it's like to be on the moon. As part of this effort, so this is an ongoing project, As part of this effort, we've created a number of early demos, which are listed here: the Lunar South Polar region, the Apollo 11 landing experience, Tranquility Base, and Selene, our first lunar city. And we also created an orbital mechanics module. By the way, a lot of the screens that I'm using for background and so on are from our virtual moon efforts so far. Here you'll see at the top, at the top right is the Tranquility Base experience, where you're looking out into the Tranquility Base through the visor on your space helmet. The bottom picture on the right is the Apollo 11 landing experience, where you get to watch the historical landing of Apollo 11 in real time from a spot standing on the surface of the moon close to the landing spot. So this is about 30 meters when the Eagle is about 30 meters from the landing spot. And the background screen is after the Eagle actually landed. So this is what we're doing with Virtual Moon. Now, one of the important components of Virtual Moon, as I said, is Selene. And that's what we're going to be spending most of our time talking about. So this is the Lunar South Polar region. It's the first demo we built for Virtual Moon. We recreated about 200 kilometer radius around the Lunar South Pole. And I wanted to call your attention to this feature here, which is the Malapert Mountain. Some of you may be familiar with Malapert Mountain. It's near the South Pole. It sits on the zero meridian longitude line, right on the center line, on the face of the moon, facing the Earth. And it's a very convenient place, for example, for Earth observing. So Selene, we're going to be talking more about it, but Selene is envisioned as a resort city, a destination resort city. So one of the people visiting the moon will be, a group of people that will be visiting the moon will be tourists, and tourists will want to have experienced the moon in all its dimensions. One of them is going to be the ability to look back at the Earth. So because we're near the South Pole, the Earth is very low on the horizon, so it's a very convenient place to do, Earth gazing, for example, which is probably going to be a very popular activity in this resort. This is where Selene will be built, right at the top of Malapert. And there will be a surface observation dome, again, to give you that direct live view of Earth from Selene. This gives you, sort of orients you a little better into where Malapert is relative to the South Pole. On the picture on the left shows how far Malapert is from the South Pole, and shows its location on the zero meridian line. And then we also have a 3D sort of rendering of what the shape of Malapert looks like. And of course, the red spot shows where Selene is planned to be built. So this is what we call the Selene reference concept, right? So we want Selene to be it'll be designed to accommodate up to 5,000 people. And we wanted to create a sort of a baseline design, which we know is riddled with design errors and maybe the wrong assumptions and so on. But the idea is to create a starting point. What we want to do really is to create a nucleation site for all of these ideas that come up in these lunar conferences about all the different technologies that we can apply and what we are envisioning doing on the moon, and kind of gather all the best ideas and see if gathering all of those and using them the right way, we could actually build something like this. Now, something like this is buildable with 100% certainty, let's say in the next 50 to 75 years. So there's no doubt in the next 50 to 75 years, we should be in position to build something like this. Now, the moonshot for this is, can we pull in that schedule and can we build it in the next 25 years? So that's what the project is about. Design a lunar city, underground lunar city, at this scale, capable of holding 5,000 people, that can be built, that is constructible or buildable in the next 25 years. So we started with this baseline design. This design is going to iterate over time, and as new experts join our team and contribute their ideas and refine the concepts, it'll iterate over time. Again, the convergence we want to achieve is a design that's actually constructible on the moon in 25 years. This is Selene in virtual moon. It's in the early construction phase. So we created a Selene construction site. What you're seeing here, so the entire Selene habitat is built underground. So it's about a 1 kilometer long tunnel with a very large central atrium, a very large cavernous space. One of the first issues we ran into is there's going to be a lot of excavated material that we have to get rid of. Now, we don't want to create sort of detract from the natural aesthetics of the moon surface. We want to minimally disturb the moon surface as much as possible. And so one of the things we thought to do with the excavated material is to create these structures, which we use as a road into Selene, and also to construct a landing pad for SpaceX transports. One other thing I wanted to point out in this picture is there's a trail of white lights or dots going off into the distance. That's Lunar Highway 1. That's a traversability study that we did that gives you a surface road from Selene all the way to the South Pole on Shackleton Crater Rim. And this is just a close-up of the landing pad, one of the landing pads for Selene. Last presentation I did for one of these events was a couple of years ago. We did a mass budget study. We said, let's limit the mass to 100,000 tons that we'll transport to the surface of the moon. If we limit ourselves to that amount of mass, could we build Selene? And so we did some conceptualization of what it would take to build something on that scale. And we came up with a calculation that says, well, yeah, it looks like at first pass, we should be able to build Selene with 96,000 tons of material to this lunar surface. And this is how we've allocated the different mass budgets. Of course, I'm not going to go through this in detail, but just wanted to point out a couple of things. So first, we don't want to be power limited. From day one, when we start construction, we want to have abundant, reliable, uninterrupted power. So we're going to use nuclear reactors, small modular nuclear reactors. We're going to land 3 of them on the surface, and that'll generate 90 megawatts of power. And with unlimited power, we can pretty much do anything we want in terms of surface operations and even, chemical processes and closing life support systems, so they're 100% recyclable and so on. There's also extensive use of ISRU. So a lot of the mass budget is allocated to bringing ISRU plants to the lunar surface to begin producing oxygen, steel, glass, sintered bricks, and other construction materials. We're also assuming worst case that we cannot convert lunar soil into growth medium for plants, because and this was discussed in the previous presentation. Vegetation plants are very important for the sort of the aesthetics of a lunar habitat, but also for the psychological well-being of the people inhabiting it. So we've allocated a significant amount of mass budget to bringing in plants and trees and so on. and soil. Again, assuming that soil, worst case, we're not going to figure out how to convert lunar regolith to viable soil. We'll ship all that soil from the Earth. We can dehydrate it and then rehydrate it when it gets to the moon. For water, again, we're assuming worst case that we're not going to be able to figure out how to easily extract water from lunar ice. So instead of bringing water from Earth, we'll just bring hydrogen, and we'll have the ISRU plants manufacture the oxygen. And with 11,000 tons of hydrogen to the moon, we can make 90,000 cubic meters of water or 35 Olympic-sized swimming pools. So there's plenty of water in Selene. And then finally, just wanted to call your attention also to steel. Because the lunar soil is rich in iron, we can just bring the additional metals that we need to make different alloys for stainless, different alloys of stainless steel and other compounds. So if we bring 12,000 tons of a combination of carbon, chromium, tungsten, molybdenum, and so on, that will allow us to make 50,000 tons of steel, which is the equivalent of 7 Eiffel Towers. And for structural applications, though, if we want to build structures inside Selene, 50,000 tons of steel, because of the 1/6 gravity, is actually equivalent to 300,000 tons of steel for construction operations on Earth. And so that's what the mass budget study first pass showed. Now, we want to make a virtual reality simulation of Selene, something that people can walk into and explore at will. But we want to go beyond that. We want to make Selene an engineering simulation. So we're going to use digital twins. Some of you may be familiar with digital twins. It's basically a virtual or digital representation of a real world object. In this case, we're looking at a jet engine. So a jet engine has certain operational characteristics. We can simulate and replicate digitally all of the functionality and operational characteristics of a complex device. And we can simulate all kinds of uses and environmental conditions and how will it operate under different loads and all of that. And then it turns out that you can take digital twins and sort of arrange them in hierarchical structures. So the digital twin of a jet engine could become a component of a digital twin of an airplane. The airplane in turn could be a digital twin component of a digital twin simulation of an entire airport. So you can simulate airport operations in great detail, all the way up to an entire city. So Selene is going to be a digital twin city with all of the engineering systems up and running and simulated as if they were actual systems with all the defined interfaces, all the defined functionality and processes and so on. Selene is going to be entirely built by robots. There'll be no human interference required. We have built these modular robots that have different exchangeable tools and appendages. And there'll be a whole army. It'll be a robotic swarm composed of maybe thousands of robots of different shapes and sizes, all the way up to maybe 50 or 100-ton robots, very large ones, because this is going to be a very large tunnel, 10 meters by 50 meters wide and 1 kilometer long. And so you'll have a mixed population of various size robots. But, things go wrong. And usually when things go wrong with these kinds of mechanical systems, a human needs to be on site to fix these problems that arise unexpectedly. Well, if we have humanoid robots, which we are assuming we will have in the next 20 years, let's say, humanoid robots will achieve the agility and dexterity of humans and maybe even surpass it. So again, no need for humans to be there. Robots can handle the entire excavation and construction process. As far as the timeline, here we're taking a Merlin method approach. We start with where we want to end. In 2045, we want to begin operations. That'll be the opening day, 2045, July 20th. Why not, right? If you're going to pick a date, might as well pick a significant one. The year 2045, January, it will begin integrated systems testing and commissioning of the entire facility. And so we know the endpoint and we work our way backwards. That's what the Merlin method prescribes, that we work our way backwards. So if we're going to be ready in 2045 to build this, what do we need to have in place in 2040? So in 2040, we'll begin a 5-year construction cycle. So it's let's see, 52 weeks a year times 5 years. It's like 265 weeks. That'll be for 1,000 flights to land all that mass on the moon. That's 4 flights per week. This is what we'll do over that 5-year period until by the end of 2044, December 2044, Selene should be fully constructed and should be ready to begin testing. And where we are now, we're not going to go through the entire timeline, but to get there, we have to start very soon, right? So we start 2025, a couple of years from now. We have to begin engineering design and establish the technology development centers. So a lot of these technologies are not quite at the point that we can currently use them to build Selene. They have to be evolved and optimized. So these are some of the critical technologies that we need: artificial intelligence, life support, power, materials, ISRU, and robotics. We have to mature these sufficiently so that they become the systems and tools and materials that we use to build Selene. We also want to build Starship. So Starship is the game changer. This is what enabled us to actually come up with a plan where this is doable. Before Starship, I don't think there was no chance, practical chance, that we would ever be able to build something as ambitious as Selene. So we could buy Starships from Elon Musk, but I think he's going to be building as many as he needs just to go to Mars. So we will just replicate Elon Musk's Starship and rocket engine factories and build our own. The other advantage of that is that we're going to be needing more infrastructure to build the entire transportation system end to end from the Earth all the way to the lunar surface. And we want to specialize transport such as space barges or tugs that operate only in space between Earth orbit and lunar orbit or Lagrange point, and then another specialized system to actually land mass on the moon, and so on. So we want to be designing and building all of that. So again, modeling after SpaceX, we'll be flexible and adaptable, and we'll have a highly skilled and highly motivated team building all of these components that we need. And we want, again, this is a resort destination. We want it to be as Earth-like as possible. It'll be pressurized to 1 Earth atmosphere, that it'll be aesthetically breathtaking, very beautiful, very warm and accommodating, ultra luxurious, and again, we're going to spare no expense to make it completely comfortable and completely safe. And now, building this in the physical world is an extreme challenge, but we think we can go through most of the steps and demonstrate the viability of this idea by doing it in the virtual world. So that's our objective with the Virtual Moon, is to build it, make it accessible, and allow everyone on Earth to take a tour through Selene, and even learn about the engineering systems, how Selene will actually work, all the life support systems, the power systems, thermal management, the food growth, and learn as much as you want. All the information will be available to explorers of Selene to learn as much as they want to learn about how it actually works. And that's it. That's our ambition for Virtual Moon and for large-scale, city, the first real city on the moon.
Thank you, Manny. Very ambitious and large-scale operation that. We do have a few questions there, which I hope we will be able to get through. Madison Fian one says, well, very innovative concept. Is Virtual Moon available for private and government use?
Virtual Moon will be available for everyone for free when it's ready. Everyone can, and we already have the demos that I spoke about. So, for example, you can actually witness the Apollo 11 landing right now. I can send you a link. If you have an Oculus headset, you can experience that right now.
Please put the link in chat. Yes.
Okay. Also, we're reaching out to different space companies to work with them, because Virtual Moon is going to be putting a premium on being highly accurate and highly detailed. So we're going back to to source information from NASA, LRO missions and other missions, and importing all of that high resolution data. So once we build a highly detailed, highly accurate, high fidelity model of the moon, of course, this has uses for space companies that have plans for moon missions.
Right. And there's a question from Marufa, well, two from Madison and two from Marufa, actually. So Marufa wonders, if thousands of robots will be living on the moon, how do you ensure the safety of human astronauts? Are you considering to ship these robots from Earth?
Yes. All the robots will be shipped pre-assembled from Earth. They'll unload themselves from a SpaceX cargo container and start scurrying about, installing the power plants so they can repower themselves after their initial charges run out, and just go to town and start construction. Humans won't be needed on the surface, but I'm sure some humans will want to visit the surface. The robots are swarms of robots. They're all controlled centrally by an AI, and humans will be able to walk around the robots completely safe, because the robots will kind of create a safety zone around humans. If they see a robot, they'll make sure that they avoid them.
Yeah, it's a programming issue, I guess. Yes. So that can probably be solved. Madison Fian would also like to hear more information about the ISRU material processing plants. Do you have any details on that, or is it just on conceptual scale?
Yeah, at this point it's still conceptual, but the first digital twin we're going to build for Virtual Moon is going to be an oxygen extraction plant. And so, we'll specify the parameters. What is the efficiency? How much power does it need to create a kilogram of oxygen? What is the throughput rate? The reliability of the plant, the size and mass of the plant, and all of that. So we're going to create that as a digital twin first, and then run some simulations with it. And then we'll also create other plants for extracting metals and manufacturing glass and all of those things we talked about.
But I got curious there. If you're not having any humans to start with, what are you using the oxygen for?
Well, because we're going to need oxygen to fill up Selene, right? Once you complete the pressure envelope and you seal it and put in the airlocks, then you start filling it up. We're gonna ship nitrogen from Earth because of the low concentration of nitrogen on the moon. So we're just going to use a number of flights, I think.
I'm not questioning that oxygen will be needed, but if you're going to build the thing first before you fill it with oxygen, I guess you need some other plants before you need the oxygen.
Yes, well, the plants also are probably not going to produce oxygen very, very fast. So sometime before Selene is fully built, you need to start warehousing enough oxygen. So when it's complete, you can fill it up, 20% oxygen.
Fair enough. Thank you for this quite interesting vision of the future. And